Okay, question 28. So we've got here x equals t cubed minus 5, y equals t to the power 4 plus 7t to the power 5. So find dy dx. Okay, so dx dt to start with. So this becomes 3t squared. Dy dt, that becomes t to the power 4 becomes 4t cubed plus 35 t to the power 4. Okay, now remember to do dt dx is helpful to get the reciprocal of this, so that'll be 3t squared, flip that, so it'll be 1 over 3t squared. Okay, so for dy dx, using the chain rule, while dy is on the top, so dy dt, dx on the bottom, so dt dx. Okay, dy dt is this here. Okay, dt dx is this here, so it's times 1 over 3t squared. Okay, all of that times this. Now there's a few ways you could write this. Okay, you could write it so you've got the whole thing divided by 3t squared. Okay, now later on in part 2 we've got to find d2y by dx squared, so it may be better because we're going to have to differentiate this again. Okay, and as it stands it's kind of sort of in a quotient format. It may be better just to split this up. Okay, so what I mean by that is divide each term by 3t squared, because the top is divided by 3t squared, so you can split it up like that, and then you can simplify down here. So the t squared goes with the cube there, so you've got 4/3 t, and the t squared goes with the t4 there, so you get t squared there, so it'll be 35 over 3t squared. Okay, it might help to do that with the second part. So with the second part, you want to find d2y by dx squared. Okay, so d2y by dx squared is, remember now, second derivative, so it's the derivative of dy dx, d by dx of dy by dx. Of course, dy dx we've already worked out in part A, and you know, right, you know that you can't differentiate this with respect to x because it's in terms of t. What you can do is differentiate it with respect to t. Yeah, that's the only thing you can do. Okay, so we're going to change this using the chain rule, but don't forget you've got a plonk of dt by dx on the end, right? So always going back to this here. Okay, you're going to use this. In effect, the dt's cancel. You can sort of see it like that, so you're left with d by dx or anything wrong. That's the chain rule, that's how it sort of works. So we can differentiate this with respect to t. So that's easy. 4/3 t, well, the t goes, so we just end up with 4/3. And then this, then bring the 2 down, so it'll be 70 over 3t. Okay, of course you've got to times it then by dt dx, which was 1 over 3t squared, and then just take that through then, so you have times each term, so it'd be 4 over 9t squared plus then 70t over 3, 9 again, isn't it? 9t squared. That t then will cancel the square, so you're left with this. Last bit then, it says when x is 3, find dy dx, d2y by dx squared, sorry. So you know this is d2y by dx squared. Okay, you know that is equal to this. Right, and they say when x is 3, find d2y by dx squared. And of course, d2y by dx squared is defined in terms of t, isn't it? As we were asked to do. Okay, this is what they said in the question, didn't they? If we look back, in terms of t. But when x is 3, then we need to just work out what t is going to be. Okay, and it's easily done because the original question tells us this, isn't it? So you know when t equals, when x equals 3. Okay, just sub it in there, so 3 equals t cubed minus 5, and you can work out what t is. Okay, so that's 8t cubed, which means t is the cube root of 8, which is 2, so t is 2. So then when you know t is 2, you can then work out what d2y by dx squared is by chucking it into what we worked out. So 4 over 9 times 2 squared plus 70 over 9 times 2. Okay, so using the value of 2 for t. So we'll get my calculator out. And you get out a nice answer for d2y by dx squared.